Welcome to The Explainer. Today, we're diving into something pretty amazing, a potential breakthrough that could help tackle one of the biggest challenges we face, the global water crisis. And get this, it starts with two things we have tons of: farm waste and sunlight. This is the story of how they could come together to change, well, just about everything.
So let's start with a big what if. What if you could take something that's usually just thrown out, like straw left over after a harvest, add a couple of all-natural ingredients, and create a device that makes pure, clean water using nothing but the sun? Sounds a little like science fiction, right?
Well, it's not. This is a real thing. Scientists have actually done it, and what you're seeing here is the proof. It's a surprisingly simple device that flat out works. But before we get into the how, we really need to understand the massive problem it's trying to solve.
Look, freshwater scarcity isn't some far-off problem. For billions of people, it's a daily reality that affects their health, their food, everything. Getting clean water to where it's needed is, without a doubt, one of the great engineering challenges of our time.
Okay, so let's get into it. You might be thinking, don't we already have ways to make fresh water from the ocean? And you're right, we do. So why do we need something new? It really boils down to one simple word: energy.
Our current methods, things like reverse osmosis, are total powerhouses. I mean, they work great, but they come with a huge price tag. They guzzle unbelievable amounts of energy and need these massive, complex, and expensive facilities. And that makes it pretty much impossible to use them in the places that often need water the most, remote communities without a lot of resources.
And this is where the hero of our story comes in. It's a brand new material called a hydrogel. You can think of it as a kind of high-tech sponge that can hold a crazy amount of water. And this particular one is made from some of the most sustainable, down-to-earth materials you can imagine.
The real genius here is in the recipe. It's so clever. Step 1, you start with wheat straw, something there's just mountains of in agriculture. You process that down into cellulose. Step 2, you mix that with alginate, which is just a natural gel that comes from seaweed. And then, for the final kind of magical ingredient, you add something called mxene, an incredible atom-thin super material that is the key to this whole thing.
So how do you turn that recipe into an actual sponge? Well, the ingredients are all mixed together and then they're freeze-cast. It's a bit like making ice, but this process creates this amazing network of tiny interconnected channels all through the material, which makes it super porous. And that structure is what gives you this durable, lightweight hydrogel, perfectly designed to be powered by the sun.
Okay, so each ingredient has a really specific job. The alginate from the seaweed, that forms the basic squishy framework that just loves water. Then you have the cellulose microfibers from the wheat straw. They act kind of like rebar in concrete, making the whole thing strong and creating these perfect little highways for water to travel through. And the mxene? That's the engine. These tiny little flakes are like nanoscale solar panels, and they are ridiculously good at soaking up sunlight and turning it into heat.
So you've got this amazing sponge. How does it actually turn salty, dirty water into clean, fresh water? Well, the secret is all about a really clever use of physics and, of course, sunlight. It's all based on this idea called solar interfacial heating. Now, instead of wasting a bunch of energy trying to heat up a whole bucket of water, this strategy is way smarter. It focuses all that solar power right on the very top surface, where the water meets the air. This causes super fast, super efficient evaporation, leaving all the salt and gunk behind, without wasting any heat on the water underneath. It's brilliant. Now, for that to work, you have to keep getting water up to that hot surface, right? And this material is an absolute champion at that. It's what they call super hydrophilic, which just means it loves water. A droplet gets sucked in less than 0.2 of a second. It's crazy fast. This non-stop wicking action is what keeps the whole evaporation engine running. And you can literally see it happen right here. These are thermal camera images. Just watch on the left as the surface goes from a cool green to a hot, hot red under a fake sun. The graph on the right just confirms it. In only 1 hour, the temperature of that sponge's surface rockets up by nearly 20 degrees Celsius. That right there is the mxene engine kicking into high gear, turning light into pure heat. So the theory sounds fantastic, right? It's elegant, it's clever, but does it actually work? Let's check out the data and see how this solar sponge held up when they really put it through its paces. All right, first key number. How much water does it make? Under the power of what they call one sun, so basically a normal sunny day, a single square meter of this stuff can produce 1.66 kilograms of fresh water vapor every single hour. To put that in perspective for you, that's about 3.5 regular water bottles. For a system that just sits there and runs on sunlight, that's seriously impressive.
Okay, now, how efficient is it? This number is pretty remarkable. Over 85% of the sunlight that hits the sponge gets converted directly into making water vapor. That means almost no energy is wasted. It's just an incredibly efficient little machine.
Of course, making water vapor is only half the job. You have to leave the salt behind. And on that front, the performance is just exceptional. The material rejects over 99.9% of the salt ions. The water you collect is incredibly pure. For instance, it takes the sodium in seawater from over 11,000 milligrams per liter all the way down to just 8. Wow! So, how does it compare to other cutting-edge materials out there? Well, as you can see, it's a clear top performer. It's got one of the highest evaporation rates on this chart, but here's the really crucial part. Look at the salinity. It does all this in water with a 5% salt concentration. That is way saltier than the ocean, and that's a condition where a lot of other materials just start to choke.
And look, for any of this to matter in the real world, it has to be durable, right? That's non-negotiable. And this hydrogel really delivers. They ran it for 10 days straight, and its performance barely changed at all. That proves it can stand up to the sun and the salt without clogging up or falling apart.
And its power isn't just limited to salt. They tested it on water that was contaminated with some pretty nasty industrial stuff, like these chemical dyes. Just look at the results for yourself. It takes that dark, toxic-looking water on the left and turns it into the crystal-clear, purified water you see on the right. Just amazing.
So the results from the lab are, frankly, incredible. Let's zoom out for a second and just ask, what could this breakthrough actually mean for the future of fresh water?
The researchers who actually developed this stuff are, as you can imagine, pretty optimistic. They concluded that this hydrogel is a highly promising platform for sustainable water purification. And when scientists say something is highly promising, that's a really big deal.
And this, right here, is why it all matters. Because it's made from cheap, abundant stuff like farm waste, and because it runs entirely on free sunlight, this isn't some pie-in-the-sky, expensive technology. This is the foundation for simple, scalable devices that could finally bring reliable, clean water to the communities that need it the most. It's a sustainable solution they could potentially build and maintain themselves.
This whole innovation just goes to show that some of our biggest problems might be solved by looking at waste not as trash, but as a resource that's just waiting to be transformed. It leaves us with one final and I think pretty inspiring question. What else could we create by turning waste into wonder?